Hello, this is Mr. Precella, and today we're going to be discussing square roots in my algebra class. And to get started with your course in Pearson MyLab, you need to log into Canvas. Once you get to your dashboard, click on your algebra course. This one I'm going to be using for demonstration purposes. It's right there. I assume most of y'all won't have a whole lot of math courses listed there. You might have your intermediate algebra if you're taking this as a co-rec course, but for that combined co-rec course, mainly use your college algebra to access your homework. Once you do, here's what the home screen looks like on Canvas. To get started with the coursework, you click on My Lab and Mastering. And when that's the first time you do it, you'll need to punch in your Pearson MyLab login if you've used it before. If not, it'll prompt you to create a Pearson login. Then say Open MyLab and Mastering. And now you're in the Pearson website. And to get started with the course, you click Assignments, and you start with lesson number 1, square roots. Now you cannot just jump around through the course. You must work through it in order. Every course has a prerequisite. So before you can click on lesson 2, you have to have completed lesson 1. That's what these green little arrows mean. That you can't do it until you've met the prerequisite. In order to do lesson 2, you have to have done lesson 1. Every assignment, test, quiz is laid out right here under assignments, okay, along with the due dates. Okay. And this is spring 2021 semester that I'm doing this. That's why the due dates are in, 2021. If you're watching this sometime after that, well then, click on your first one, and every assignment here has some media that will help you punch in the stuff. At first when but you got to click on them to get a green check. Okay. Once you've clicked on them, that even includes the textbook and videos. Now, if you might want to watch the video, which is the one I'm making right now, by the way, and you might want to read the textbook. But for our purposes, I just wanted to get the green check so I can start doing the problems. And we are going to discuss square roots today. So let me go ahead and pull up the first question. And I don't know that you need to be seeing me anymore, so I think I'm going to just X myself out. You don't need to see me as I'm doing it. You can just listen. And here is our first assignment, or our first problem. It says evaluate the square root. Well, I'm sort of making a huge assumption that you've seen square roots before. Let's see. What is a square root? Well, this symbol right here is called formally a radical symbol, but when we see it, we read it as square root, as opposed to number 49 is under there. The square root of 49, what that's asking you for is what number could you square, in other words, multiply by itself, in order to get 49? Well, 7. 7 times 7 is 49. What about the square root of 25? What number can you square, multiply by itself, to get, or times itself, I should have said, in order to get 25? Well, 5 times 5 is 25. So, the square root of 25 is 5. there's some square roots that we know just from the multiplication tables, and I think I'm going to go ahead and write those all out at the top of this page. These numbers are called perfect squares. And let's see. What, like 49 and 25, you know those square roots just from the multiplication tables. 1 times 1 is 1, I won't bother writing that. 2 times 2, 3 times 3, 4 times 4. Is it clear what I'm doing? I'm writing out the numbers whose square roots you know. Just like the square root of 16 would be 4, because 4 times 4. Then the next square root, 5 times 5, or the next perfect square, I mean. 6 times 6, 7 times 7, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11, 121, 12 times 12, 144. It's getting bigger now. 13 times 13, I think that's the last one I'll write. That's 169. You might want to punch that into your calculator if you doubt it. Okay. But these are numbers whose square roots we know just from knowing the multiplication tables. Now, the natural question to ask is, well, how would we simplify something that isn't one of these perfect squares if we don't want to just write out a lot of decimal numbers? Okay? Like the square root of 49 is 7. What about the square root of 50? Well, the square root of 50, it would be 7 point something, right? If the square root of 49 is 7, the square root of 50 is 7 point something. So, rather than punching in decimals, we aren't going to use a lot of decimals this semester. In algebra, we try to avoid decimals unless we're talking about something like dollars and cents, okay? So, there's a couple of ways to simplify square roots when the number under it isn't a perfect square. The way I prefer to do it is to rewrite it as multiplication. Okay? What perfect square divides evenly into 50? What's the biggest one of these numbers that divides evenly into 50? Like 25 divided by 4. Well, no, that's not a... 25 divided by 9. 16 doesn't divide into it. But 25. 25 divides evenly into 50. 25 times what would give us 50? 2. Now, we can simplify this square root of 25 by replacing it with a 5. So this red square root of 25 becomes a red 5, and then we just leave the square root of 2 there. That's how I'll simplify square roots that are not perfect squares. Okay? What I'm doing is I look through mentally which numbers up here. What's the biggest one of these numbers that divides into 50? So here's what I was doing. Oops, let me turn it on. 50 divided by 4. Is that a perfect? No. It's a decimal. 50 divided by 9. And I'm doing this just as my thought process. 50 divided by 16. That doesn't divide into 50. But all of y'all know that 25 divides evenly into 50. So you choose the biggest perfect square that divides into 50 and rewrite it as multiplication. I think I've done enough for us to start doing problems. So let's see. Let's do this problem number 1. Evaluate the square root. It says the square root of 100. Well, heck, there's not really any work to write out here. We can just type in the answer here. And this is my first problem on homework lesson number 1. The square root of 100. What number can I multiply by itself to get 100? Well, 10. 10 times 10 is 100. I check my answer. I could just hit enter if I wanted. And it says, okay, let's go on to the next question. Now, if on the other hand you think, oh wow, I need to do another problem like this. Well, just down here, click similar question. Square root of 25. Notice, we're still on problem number 1. I just chose to do another one. Sometimes you might work a problem and decide, oh, I need more practice with it. Okay? But now let's go on to problem number 2. The square root of 225. Oh, wee. I wonder if 225, is that a perfect square? We've been up through 169 listing our perfect squares. If I look at my calculator, if I clear this, and the square root key is up here above the x squared. Second square root 225. I know what that is. That's 15. 15 times 15 is 225. So I'll just move that over there and punch in a 15. Well, actually, we know the answer is 15. Since this is the beginning of the semester, let me just demonstrate that you can rework the problems until you get 100. Okay? Let's suppose I put 10 there. That would be wrong, and look what happens. It tells me when I try to check it, oh, you know, that's incorrect, and it gives you a little hint. Let me guess again. Let me put 110. Certainly a wrong answer. I'll check the answer. Still wrong. It says try again. At this point, this is my last chance. Down here it says final check. If I get it wrong, it's going to give me an X. Let me just say I put 40. Again, that's wrong. We know the square root of 225 is 15. How do we know it? We punch it in our calculator. 15 times 15 is 225. But I'm just trying to illustrate what to do if you're getting these answers wrong. Final check. Oh, that was wrong. It tells me the correct answer. And it gives me a choice. Either move on to the next question or say similar question. This is one of those times, don't move on to the next question. Go say similar question and get this one right. Oh, well, now look at my new number 2. Square root of 100. Well, I think we may have already even done that one. I'll punch in 10, and it's right. And we'll now move on. I want to demonstrate. Notice we now have the green check there, not the X. You'll notice your grade is changing as you put in the answers. Okay? You don't do anything to submit your work or your here. It'll be updating it automatically as you get either wrong or right answers. Number 3's. Oh, square root of 50. Well, that's one we've already done. Look at that. Now remember doing that one, the square root of 50? You rewrite it as 25 times 2, so that's 5 square root of 2. Now we get back over here and punch in right here. Look, once you click in the box, it shows you the symbols down here. I'm going to punch in 5. Square root is right there. 2. Check the answer. Let's see what the next question looks like. Okay. Simplify by factoring the square root of 175. Let me write that one down. Now, 125 is not a perfect square. How do I know that? Well, if you doubt me, punch it into your calculator. Second square root, 175. It's going to give me a decimal number. So it's not a perfect square. So it's one of those that we need to simplify using our list of perfect squares. So which perfect square divides evenly into 125? Let's see. Let me move my calculator off to the side. Well, we want to choose the biggest one. And so here's just my thoughts. I'm just going through the list of perfect squares. 4 certainly doesn't divide into it. Maybe 25. I think 25 divides into it. Let's see, does 25 divide into 175? Yes, by 7. You could play around and see if any of these, 36, 49, no number bigger than 25 divides into 175. So we'll write this as 25 times 7. The red square root of 25 becomes a red 5 square root of 7. 5 square root of 7. Let me pull this up and click up. Notice there's no tools down here yet. Okay? You've got to wait. You got to click here. Once you do, click up there. That's when you see the little tools that you can use. So I'm typing in a 5. Then I need that square root of 7. Now, check my answer. Okay. So let's move on to problem 5. The square root of 39. Simplify the square root. Assume all variables represent positive numbers. There's no square roots. Well, 39 is certainly not a perfect square. Okay, remember our list of perfect squares? Here they are. 39 is not a perfect square. Do any of these numbers divide evenly into 39? 4 doesn't divide evenly into 39. Neither does 9, 16, 25. Don't really need to go any larger. So we're looking at the square root of 39. Notice you can't rewrite it like this using a perfect square. So all we can say is can't be simplified. I think that's the second option. Okay. 39. Let me see here. The square root of 39. You would click here if we were going to be able to simplify it. But here it says it's already simplified. It can't be simplified anymore. So there it is. Okay. What about the square root of 72? Square root of 72. This is a good example. Let me look back at this. Square root of 72. Well, look at my perfect squares. Here we want the biggest perfect square that divides evenly in there. Let me clear out all of that. If I'm at 72 divided by 4. Oh, okay, so 4 divides into it. But the biggest one. 72 divided by 9. Look at that. 9 times 8 is 72. So you might think, oh, well, wait, we can use that. You want the biggest. Okay? Is there a bigger number that divides evenly into 72? A bigger perfect square? 36. Have y'all figured out 36? What's 72 divided by 36? 2. So we will rewrite 72 as 36 times 2. And then we can simplify that. Let's see, there'd be a red. What's the square root of 36? Well, a 6. So I'll write a red 6. And the square root of 2, that's one of those numbers. It's as simplified as it's going to go. So the square root of 72, we'll write as 6 square root of 2. So come over here, pull up the homework. Square root of 72 is notice once I click, you get the tools. 6 square root of 2. And hit enter or check. Either way, it'll check it. Now, square root of 24. Let me write this one down. 24 is not a perfect square. How do I know that? Well, I'm thinking about those perfect squares. Let me see. Let me pull this out. See, 24 is not a perfect square. There's no number. 25 is, but not 24. So which one of these perfect squares divides evenly into 24? I'll give you a hint. There's only one, and I think it's the first number listed there. 4. Is 4 the only perfect square that divides evenly into 24? So I would write this as 4 times 6. Or square root of 4 times square root of 6. And then I would simplify with a red 4. I'd put a red 2. Square root of 6. Sometimes students say, wait a minute, do I have to write out everything you're writing? I can go from here to here without showing that. And I always say, your goal is different from my goal. Your goal is to get the correct answer as quickly as possible. Well, without cheating, okay? But my goal is to try to show my thought process, and that's what I'm doing here. I'm thinking of 24 is 4 times 6, and the square root of 4 is 2. Okay? So I'll punch in 2 square root of 6. Up here, 2 square root of 6. Enter. Ooh, square root of, is that 1,000? Oh, square root of 1,000. Yep. 1,000 is not a perfect square. How do I know that? Well, I know that. If you doubt it, just punch in your calculator. Punch in square root of 1,000. Oops, let me turn this on. Okay. I'll punch in square root of 1,000. You'll notice I'm being very sloppy. I'm not closing the parentheses. I probably should. Because in some calculators, if you don't close those parentheses, it'll give you an error or a wrong answer. So there. So the square root of 1,000 is some big decimal number. That's called an irrational number. So we are going to ask ourselves, which perfect square, what's the biggest perfect square that divides evenly into 1,000? Well, looking through these, if you want to, you can punch them through, but I bet most of y'all can figure out, wait, 100. 1,000 divided by 100, doesn't the 100 divide evenly into 1,000? 10. So we can rewrite our 1,000 as 100 times 10. And then we have a red, what? A red 10 and a green, oops, not square root of 6, square root of 10. The green square root of 10 I just carried over here. Oh, let me move my calculator out of the way so I can see what I've written there. So it should be 10 square root of 10. That's what I'm going to punch in. Here, 10, hit the little square root, 10, and enter or check. Okay. Oh, square root of 50, I think we've already done square root of 50, haven't we? They sure do like to do that square root of 50, don't they? Square root of 50 is 5 square root of 2. Let me go ahead and just punch that in and then say similar question. So we can do one more example of it. So it's 5 square root of 2. We had written or thought of 50 as 25 times 2. The square root of 25 is 5. Oh, well, here's yet another one. Okay, 153. Oh, wow. 153. 153 is certainly not a perfect square. See, it's 12 point something. So let's just go through 153. It's certainly not divisible by 4. Notice how you're getting a decimal number. 9 doesn't divide evenly into it. Well, if 4 doesn't, 16 doesn't, but I'll go ahead and do it. Oh, wait, 9 does! Oh my gosh, I'm not even paying attention. I was here thinking that 153 was a prime number. No, it isn't. 9 times 17. Great. Well, still, let's make sure there's no bigger perfect square. 153 divided by 25. Nah. 153 divided by 49. No. Oh, so what did we decide? 153 divided by 9 is 17. And 17 is a prime number, so it can't be broken any further. So let me go ahead and write this one down, just to try to write out my thought process. Pull up my square root of 153. We would write that as 9 times 17. Is it clear how I'm getting these numbers? Where's my calculator? 9 times 17 is 153. I think 9 is the only perfect square that divides evenly into 153. I said I think, but I really mean I know. Okay? So I can then simplify this by replacing the green 9, the red 9 with the red 3. And the square root of 17, that's as simplified as it's going to go. So 3 square root of 17. Punch that in. Square root of 153 is 3. Hit my little square root button. 17. Now, number 11, square root of 90. Square root of 90. Square root of 90. Ooh, I'm getting toward the bottom of this paper, ain't I? Well, what perfect square divides evenly into 90? 4, 9, 16, 25, 36. Only one listed up here that divides evenly into 90 is 9. We could think of that as 9 times, what, 10? So the red 9, square root of 9, we can replace with just a red 3. And the square root of 10 stays under the square root symbol. Okay. So 3 square root of 10 is the answer that I'm going to plug in here. 3 square root of 10. Okay. So that's how we simplify square roots that aren't perfect squares. Now, on problem number 12, it says multiply and then simplify your answer. Okay, so let me get a new sheet of paper. This is problem number 12. Let me write it down. It's the square root of 5 times the square root of 15. Well, to multiply oh, oops, to multiply square roots, you just multiply what's under the square root together. Square root of 5 times the square root of 15. We'll call that the square root of, multiplying 5 times 15. Do I need to get my calculator or just do it in my head? 5 times 15, is that a 75? So to multiply square roots, you multiply what's called the radicand together. R-A-D-I-C-A-N-D. That's what you call the numbers under the square root symbol formally. Or you could just call it the numbers under the square root symbol. Okay? So, to multiply two square roots, you multiply the numbers under the square roots together. So we've done that. Now we've got to simplify it. Well, you simplify it the way we were simplifying earlier. What's the biggest perfect square that divides evenly into 75? Well, notice I stopped right here. Isn't it 25? What's the square root of, or what's 75 divided by 25? Is it 3? How am I getting these numbers? My calculator. If I put in 75 divided by 25, it's 3. Now, simplifying this, it's the same way we were doing it earlier. Square root of 25, what red number am I going to write? Let me get my calculator out of the way. What red number am I going to write? Well, a red 5. Square root of 3. So the square root of 5 times the square root of 15 is 5 square root of 3. Come over here. Notice there's no tools down here yet. I've got to actually click in the box. Now I can punch in 5. Hit the little square root key. 3. Okay. Let's look at number 13. The square root of 11 times the square root of 11. Well, square root of 11 times the square root of 11. Well, if we do it the exact same way we did this one up here, you just multiply the 11 times 11. Okay? 11 times 11, is that 121? Yeah. So I multiplied the 11 times 11, and now I need to simplify square root of 11. Well, am I going to have to do this, or is 121 a perfect square? Well, yeah. What's the square root of 11? Well, you have it written right there. 11 times 11 is 121. I'm wondering if we could make a rule, the square root times itself. If you have the same number under both square root symbols, could we just say, okay, skip that step. If it's the same number here and here, could we just go to that? Let me go ahead and punch that 11 in, just so you'll see that it's right. And maybe we'll say similar question once I get it right, instead of going on. Let's say similar question here. Square root of 31 times the square root of 31. The square root of 31 times the square root of 31. Well, what's 31 times 31? Well, that's 961. And what's the square root of 961? Square root of 961 is 31. So I'll ask you again, oops, this is not number 14, this is still a number E, another 13. I'd click similar question. So, what are y'all thinking? Are y'all thinking that if we have the same number here and here, we could just skip to this statement, to this number? Here's a rule. Here's a rule we'll use off and on all semester. The square root of A times the square root of A. If you have the same number under the square root symbols, it's just equal to A. You don't need to write this separate step here and here. Okay? Also, another way you might see that rule stated, and this is an important rule, I'm going to put a red star out beside it. We'll use it all semester. Instead of saying times itself, we could have said this. The square root of A squared. That's another way you see this rule stated. Squared means times itself, doesn't it? It's just equal to A. When you look at it written like this, we say a square and a square root cancel each other out. Okay? So let me go ahead and... Oh, you see I punched in the 31, but let me go ahead and do that. So you'll see it's right. And I'm going to X this and say one more similar question. The square root of 29 times the square root of 29. Is this easy or hard? What am I going to type in here? Well, just a 29. There. So, we'll remember, or try to remember this rule. We'll use it all semester long. It'll pop up. Square root times itself, or square root squared. They both mean the same thing. It's just whatever's under that square root symbol. Okay? So, let's see the next question. Okay, well, the square root of 2 times the square root of 6. We can't use that little rule there. This is problem 14. And you write it down. Square root of 2 times the square root of 6. We don't need a calculator to multiply 2 and 6. That's a 12. And 12 isn't listed up here as a perfect square, is it? Well, which perfect square divides evenly into 12? How about 4? Is 4 the only perfect square that divides evenly into 12? So we think of 12 as 4 times 3. The square root of 4 is 2. The square root of 3 is just a square root of 3. Okay. So 2 square root of 3. 2 square root of 3. Check your answer. That was number 14. We're on to number 15. Oh, number 15, we're adding 2 square root symbols. So how do we add square roots? That's what number 15 is going to demonstrate. We have 5 square root of 2 plus 4 square root of 2. 15. In order to add square roots, you're going to combine like terms. There's a phrase from algebra that you hear all the time. Like if you were going to add 5x plus 4x, you could say, okay, that's 9x. That's called combining like terms. But if it had been a 5x plus 4y, you can't combine those. You would just have to leave them like that. What I'm saying here is if you have a square roots, if you're adding square roots, you just combine the numbers in front, combine the like terms. You don't change the square root. here, to add square roots, you do not add the numbers underneath them. Like 5 square root of 2 plus 4 square root of 2, that's sort of like 5 apples plus 4 apples. That's 9 apples. 5 plus 4, 9. Leave the square root of 2. So 5 square root of 2 plus 4 square root of 2 is 9 square root of 2. To add square roots, you just add the numbers in front. Don't add the radicans. Don't add the numbers under the square root symbol. Okay, let's see. Here on number 16, there's really not a lot of work to do. 2 square root of y plus 3 square root of y. The instructions say add, simplify by collecting like radical terms if possible. Oh, and then they say assume that variables represent non-negative numbers. We'll discuss more of that the next time while they're saying that. But, okay, 2 square root of y plus 3 square root of y. You just add the numbers in front of the square roots. That's a 5 square root of y. Now, if it had been x on the first one and y here, you couldn't combine them. Okay? You would just have to leave it as it is. Okay? Number 17. Let me write that one down. Number 16, I didn't write down. I just punched in the answer. 6 square root of 6 minus 3 square root of 6 plus 4 square root of 6. Okay, so I've written it down. Okay, so 6 square root of 6 minus 3 square root of 6 plus 4 square root of 6. Well, the square root of 6's aren't going to change. You leave those square root of 6. Don't get a 18 or something. You just add the numbers or combine the numbers in front. 6 minus 3 is 3. Plus 4 is 7. And leave the square root of 6 as it is. When you're adding square roots, you do not combine the numbers under the square root symbol. So just leave it as 7 square root of 6. 7 square root of 6. Check it. Okay. A natural question to ask is, well, what do we do if there's not the same numbers under the square root symbol? Well, sometimes you just have to say can't be simplified any further, okay? But one of the things that people think about algebra being difficult is the way it just builds. You learn one topic and then you keep building on that. We began the lesson discussing simplifying things like square root of 50, okay, numbers that aren't perfect squares, okay, and now we're going to be using that. Let's look back at this one. So let me write it down. This is number 18. 3 square root of 50 minus 9 square root of 2. 3 square root of 50 minus 9 square root of 2. Well, in order for us to combine these, we need the same number under the square root symbols. Here we had 2 and 2, and here all of them are 6s. So So the natural question is, could we somehow rewrite these square roots so we have the same number under the square root symbol? And the answer is yes. We know how to simplify the square root of 50. That's what we were doing over here, right there. So I'm going to simplify the square root of 50, and hopefully I'll wind up with a 2 under the square root symbol. Let's see. I'm just going to write down the 3. And I'm simplifying square root of 50 by thinking of it as 25 times 2. Then we have a 3. That red 25, square root of 25, I could just write as a 5. Square root of 2. Now this is not 35. It's a 3 times square root of 25, or 3 times 5. I can write that as 15 square root of 2. Now let me go ahead and carry down this minus 9 square root of 2. Is this problem similar to, say, number 15? Now I think it is. This is the most basic form of problem solving. If you know how to do one problem, and you're confronted with a new problem, try to make this new problem look like that one you know how to do. We now have it written as square root of 2 minus square root of 2. We can do that. 15 square root of 2 minus 9 square root of 2. 15 minus 9 is 6 square root of 2. I'm doing this problem the same way I did number 15. Okay? But I first had to simplify the square root of 50. Notice how the course is building. That's why there's those prerequisites. You can't just jump around in the course. You move smoothly through it. Everything we're doing here, you're going to need to be able to do in lesson number 2 when we discuss something called complex numbers. Now, let me come over here and punch in, what was my answer? A 6 square root of 2. Okay. So, let's see. At this point, we've multiplied some square roots. That's easy. It's just multiply the numbers under it, okay? We've added some square roots. It's not hard, but you might have a number under the square root that you got to simplify. Okay? After adding and subtracting. And let's see, what is this next one? Ooh, it's right there. Move on. It's something called rationalize the denominator. Well, let me get a new sheet of paper. What does it mean to rationalize a denominator? To rationalize a denominator means to rewrite the problem or the fraction so that there is no square root in the denominator. And there's a little process for doing that. And I'll do problem number 19 to illustrate. It's the square root of 15 over 2. Well, notice the 15 and the 2 are both under the square root symbol. So 15 and the 2 are both under that square root. This square root symbol is applying to all of that. So I'm going to go ahead and write it like this. Square root of 15 over square root of 2. Both of these numbers are under the square root symbol, so I've written it with 2 square roots. We want this fraction written where there's not a square root on that bottom. Okay? We don't want the denominator under a square root symbol, is another way of saying it. Well, here's what we're going to do. It goes back to something that I stated. Where's my red star rule? Right there. Y'all remember that red star rule? A square root times itself is just whatever's underneath here. And that looks like a 3.1 maybe, but it's not. It's just a 31. But from what I can see, it looks like I have a point there. It's just 31. There's no decimal point there. Square root of 11 times the square root of 11. So what we're going to do on this one, let me write it. Square root of 15 over square root of 2. We're going to multiply above and below by the square root in the bottom. Let's multiply above and below by the square root of 2. So if someone says, how do you rationalize the denominator? You say, multiply above and below by the square root in the denominator. Okay? There's a square root of 2 in the denominator. So we multiply above and below by that. And look what's going to happen. On top, square root of 15 times square root of 2. That was the sort of stuff we were doing right out here. To multiply 2 square roots, just multiply what's underneath there. So that would be a square root of 30 on top. Square root of 2 times the square root of 2. Well, I guess you could put an extra step, say square root of 4, which is 2. Or you could just skip straight to 2. That's that rule that we have here. Square root times itself. So square root of 30 all over 2. What we've just done is called rationalizing the denominator. Let me punch it in. I want to show y'all how to punch something like this in here. Punch in square root of 30 all over 2. I'll click here, and right here is a fraction template. I'm going to put that up on top. Square root of 30. Now move to the bottom. Right there. Punch a 2. There it is. Square root of 30 over 2. Enter. Let's do another one. Number 20. Okay. Number 20 says rationalize the denominator. Let me write that down. Is that a 21 square root of 5 all over 5 square root of 7? So 21 square root of 5 divided by 5 square root of 7. Well, here it's already written with the square root in the bottom. So we need to rewrite this problem so that there's not a square root in the bottom. You do that by multiplying above and below by the square root that's in the denominator. Let me write that out. Multiply above and below. So you're just multiplying by 1, which doesn't change anything. Multiply above and below by the square root that is in the denominator. Denominator, that's the one on bottom. Over here we multiplied above and below by 2 because that is the square root of 2. Because that was the square root in the bottom. Here we're going to multiply above and below by square root of 7. Sometimes some students will say multiply by 5 square root of 7. Well, you're just making the numbers bigger than you need then. Square root of 7. Square root of 7. Okay. So this is the last problem in the assignment, so it's got to be the hardest, right? Multiplying straight across here. There's nothing to multiply the 21 by. It just stays 21. What number are we going to have under the square root now? Well, to multiply square roots, you just multiply the numbers under there. That's what I was trying to show you when we did problem number 11. Once again, notice how it's building. 5 times 7, 35. So we have 21 square root of 35 on top. Now the bottom's going to be a little tricky. The square root of 7 times the square root of 7, that's just a 7. But don't forget we have this times 5. 5 times 7, 35. And before we punch that in, we can actually simplify this fraction here. Notice there's two numbers that neither of these are under a square root symbol, so we can just simplify those the way you would reduce a normal fraction. What could I divide above and below by here? Let's see, well, 7. The 7 divided into these, 21 divided by 7 would be 3. 35 divided by 7 would be 5. So I'm reducing 21 over 35 the same way you reduce any fraction. I'm reducing this fraction, 21 over 35, by dividing above and below by 7. So that would be a 3 and a 5. So 5 square root of 35 is our answer there. 3 square root of 35 all over 5. Maybe I said that wrong. Did I say that wrong? Here's how I type it in. I'm going to click the fraction bar, and up on top I'll type in 3 square root 35 all over 5. You'll notice I did have a 95.07 on the homework assignment, but as soon as I click there, I have 100. Okay? You know what? Let's do one more. We have a little bit of time. I'm just going to say similar question, and we'll do one more problem, number 20. Okay? Oh, well, it's not changing it very much, is it? Let's see. Let me write this one. Here's another number 20. 49 square root of 5 over 5 square root of 7. Well, it's similar. Very similar. Well, you multiply above and below by the square root that's in the denominator. So the square root in the denominator is still a 7. So we write times square root of 7 over square root of 7. And on top we have a 49. And what number will be under the square root now on top? 35. And what about on the bottom? Oh, wow, this is very similar. Well, it said similar question, so the square root of 7 times the square root of 7 is just a 7. Times 5 would be a 35. And we can reduce this fraction by dividing. 49 over 35. Let's see. I can divide both of those numbers by 7. So what would be on top here? 49 divided by 7 would be a 7. 35 divided by 7 would be a 5. Notice it's very similar to the other number 20. That's why if you get it wrong, then you can do another one very similar to it. Okay. And what am I going to type in here? I click here. I click fraction. I type a 7 and a square root of 35 on top. I put a 5 on the bottom. And then I'll say check answer. And I still have 100. I've already finished the assignment. So to get out of it, I'll just say save. But as soon as your grade starts changing, the teacher grade book changes too. So you don't really do anything to submit the grade. I'll just say save it. And let me look back over here. There's the homework. If I look in grade book at this point, I have 100. Okay, on my first homework assignment. Spent 54 minutes doing it. Okay. Well then, oops, back home. Next, we can notice now you can work on the next assignment. Okay? But you can't move to assignment 3 until you've done assignment 2. This stuff builds. So that's for your own good, walking you through there. If you just try to jump into assignment 2, you're probably going to have some trouble because you would need to know how to simplify these square roots. Okay? But anyway, this is Mr. Precella. And we'll be discussing complex numbers the next time. So I hope you have a good day. This is right here in the middle of the pandemic. The vaccines are coming out, but slowly. Hopefully you and your family are staying safe. Stay at home. Do your online math and don't get sick. Okay? I hope you have a good day and thank you for listening and watching.